Hi, in this session we will discuss about the phasor representation of the alternating quantity, and also we will take some examples on uh, calculating the parameters like average value uh, and how we can represent uh, instantaneous current or voltage, and also the RMS value, form factor, peak factor, etc. And let us start with the phasor representation of the alternating quantity. First, we will try to understand what is meant by phase. So here uh, we know that the alternating quantity will changes its magnitude and direction at a regular interval of time. Hence, it is necessary for us to know what is the condition of alternating quantity at any particular instant. Uh, and the location of the condition of alternating quantity at any particular instant, we call it as phase. I repeat, the location of or the status or condition of the alternating quantity at any particular instant is known as its phase. Okay, what is mean by phase difference? Whenever we consider any two alternating quantities, could be either two voltages or two currents, or one voltage and one current having the same frequency, and they may not pass through the same point at the same instant. That is, one quantity may pass the say the origin or zero value or the reference value at some time interval, and the other quantity may pass or cross the zero or reference value at some other time interval. Okay, so I repeat, whenever we consider any two alternating quantities, it means any two voltages or two current, or one current and one voltage, uh, and both having the same frequencies. It is not necessary that they have to pass through any particular point at the same instant. So one quantity may cross the zero value and achieve the maximum value at one time interval, let us say at time t1, and the other quantity may start its reference value from its reference value, and it may reach the maximum value at some other time interval, let us say t2. So the difference between the phases can be measured by the angular difference, or the phase difference is measured by the angular difference between the point where the two curves cross the base or the reference line in the same direction. Hence, we can measure the phase difference by the angular difference between the 2 points where the curve crosses base or the reference line in the same direction. Okay, so the quantity which is ahead in phase, we will call it as leading quantity, and the quantity which is and the other quantity we call it as lagging quantity. I repeat, the quantity which is ahead in phase we call it as leading quantity, and the other one we call it as lagging quantity. So we will understand these terms in better with these diagrams, and also we will try to understand the other terminologies, that is what is meant by in phase, what is meant by in phase opposition, and what is meant by quadrature phase shift. Okay, so looking into this first figure, here we have considered the two alternating quantities, and here I have taken the currents, different currents, I1 and then I2. So this quantity which is represented with the black lines, let us call it as I2, and the one with the blue lines, let us call it as I1. So here let us just observe at the starting point, that is at a 0. So they both are starting at the same time interval and they are moving in the same direction. Here I1 is moving and it is reaching its maximum value at this particular point, and in the same direction even I2 moves and it is reaching its maximum value at this particular instant. See, at this particular instant, both the I1 and I2 are achieving their maximum value, and again further they both are decreasing and reaching the 0 value, and again in other direction they crosses or they are moving at the same interval. So what we can say, such a nature of the two alternating quantities, we call them as in phase. Okay, that means in phase means the two alternating quantities are said to be in phase with each other if they passes through the 0 value at the same instant and rises in same direction as represented with this diagram. I repeat, the two alternating quantities are said to be in phase if they pass through the 0 value at same instant and rises in the same direction, then they are called as in phase. Okay, so we can clearly observe from this diagram. They are starting at 0 value, rising in the same direction and they are reaching the maximum value at same instant, and it continues. Right. And so this in phase, we can represent the vector diagram of I1 and I2 as is being represented with these arrow lines. OA is nothing but the vector representing the alternating quantity I1, and OB is nothing but the vector representing the alternating quantity I2. Here I1 and I2 are nothing but the maximum value of the alternating quantity I1 and then I2. Okay, we can also represent them as IM1 and then IM2. Okay, so here length of the vector will be depending on the maximum value of I1. That is OA is nothing but the maximum value of the alternating quantity I1, and OB is nothing but maximum value of the alternating quantity I2. Okay. So these two vectors are represented in parallel. It indicates that they both are in phase. Okay. So let us take the other condition, in phase opposition. Okay. So looking into this second diagram, here again we have considered the two alternating quantities, two different currents I have taken, I1 and then I2. Okay, right. So here you can observe that I1, the black line, it is and this blue line, they are when we just look at the 0 or at the reference value, they are starting at same time, but they are moving in an opposite direction. See, the black line, it is moving here upward, and the blue line, it is going in an opposite direction, downward. Okay, right. So we call such quantities are in phase opposition. That is, if the two alternating quantities passes through the zero value at the same instant, that means this one, they are passing the zero value at same instant, but rays in opposite direction. They are moving in an opposite direction. So such quantities are called as in phase opposition, and the phase difference between them is, we can clearly observe, it is 180 degree. Whereas when the two quantities are in phase, there is no phase difference. There is zero phase difference. Therefore, with the parallel lines, the vector diagram can be represented. For the second case, that is in phase opposition, there is 180 degree phase shift. So, the vector diagram we can represent for I1 and I2 as, see, I1, I have considered the positive value with respect to the x-axis. So, we have represented here with the vector OA. And the I2 can be represented with the vector OB, but its direction is in other way, towards the negative value. Okay. Now, finally, in quadrature, what is meant by the two quantities are in quadrature with each other? If the phase difference between the two alternating quantity is 90 degree or pi by 2 radians, then we call such quantities are in quadrature with each other. So, this diagram represents in quadrature in a better manner. Again here, let us consider the two alternating quantities I1 and then I2, two different currents I have taken. We can, as I said earlier, you can also take one quantity as a current and other quantity as voltage, or you can also take two different voltages. Okay, right. So here, looking into the first I1, here the one which is represented with this black line, or with this waveform, here it is crossing, it is starting at the zero value and it reaches its maximum value at 90 degree, and then it reduces, becomes zero at 180 degree, and further increases and becomes zero at 2 pi. And just look at the second diagram, that is I2. So it actually starts at 90 degree at pi by 2 and reaches its maximum value at pi, and then it moves further. So just look at the phase difference between the two quantities I1 and I2, it is pi by 2. So there is a 90 degree phase shift or phase difference. There is 90 degree phase difference between I1 and then I2. So we can represent with a vector diagram, so which we have shown here. I1, let us assume the I1 is having the phase value of 0 degree. So we can represent along x-axis with the vector OA, and I1 is the maximum value of I1, the first current, and the second current I2 can be represented, and it is in having the phase difference of 90 degree compared with I1. Therefore, we can represent it vertically upward along y-axis. We can represent, because there should be a 90 degree phase shift between I1 and then I2. Okay. Therefore, the second quantity I2 can be represented with a vector OB, and it is acting vertically upward. So, this is the vector diagram representing in quadrature. Fine. Now we will take some simple examples, and we will see how the different parameters can be calculated for an alternating quantity. So let us take the first problem. An alternating EMF is expressed as E is equal to 200 sin 314t. Find the amplitude, frequency, instantaneous value when t is equal to 1 by 200 second. Okay, so they have given the instantaneous value of the EMF. E is equal to 200 sine of 314t. So we will compare this given expression with the standard expression for EMF, which is Em sine omega t. And comparing these two, we can just clearly see the maximum value of the voltage Vm is nothing but 200 and omega is nothing but 314 radians per second. Therefore, the amplitude is 200 here. Frequency we can calculate with the given omega value. Omega value is 2 pi f, we know, and they have given it as sine of omega t is the general expression. So omega is 314. So on simplifying, we'll get the frequency as 50 Hertz. Okay, instantaneous value of the voltage can be calculated by substituting t here in the given expression. Okay, so this given expression, let us substitute the value of t, and the value is 200 volts. So we can find in terms of angular radians or in terms of degrees, that is by taking theta as radians or as degrees. Okay, second example, the alternating current has a peak value of 1.414 amps and its frequency is 100 Hertz. Write the mathematical expression for the current. So we have to write the expression for instantaneous value of the current I. Okay, so we know that I is equal to Im sin omega t. So we have to obtain the mathematical expression for I from the given values. So they have given the maximum value or the peak value here 1.414. Therefore Im is 1.414. and frequency is been given as 100 Hertz. So let us substitute the value of Im and also f. So in I is equal to Im sin omega t, omega can be expressed as 2 pi into f. So we will substitute f and Im. That gives us the value of I as 141.4 into sine of 628 t. Okay. Let us move to the third example. An alternating current of frequency 60 Hertz has a maximum value of 12 amps. Write down the equation for instantaneous value. Find the value of current after 1 by 360 seconds. So this is the given time period. Time taken to reach 9.6 amps for the first time. Assume time as 0 when the current wave is passing through the 0 and increases in the opposite direction. Sorry, in the positive direction. Okay. So let us first note down the given values. So we have the frequency as 60 Hertz. The maximum value of the current as, that is Im is 12 amps. And we have to first find the instantaneous value of the current, that is I is equal to Im sin omega t. So for that we know Im, but omega value we have to find. So frequency is been given. By using that, let us find omega. Omega can be expressed as 2 pi f. So f is 60 Hertz. So with this we will get 377. And instantaneous value by substituting in this equation we will get 12 sine 377 into t. The second thing is find the value of current. So we have to find current when time t is equal to 1 by 360 second. So we will substitute the value of t in this 12 sine 377t equation, and we will find its value, and it is, we have calculated, and its value is 10.3924 amps. Finally, the value of time we have to calculate when the current is 9.6 amps. Again, we will take the same 12 sine omega t equation, and I, they have given it as 9.6 amps. Now we will have to calculate the time interval. Therefore, from this given information, the time interval can be calculated, and it is 2.459 milliseconds. Okay, that's all in this session. Thank you.